How well do we truly know our own cosmic neighborhood? You might think we've charted pretty much everything swirling around our Milky Way galaxy, right? But what if some groundbreaking new research suggested our galactic home is far more bustling, maybe more crowded than we've ever imagined? Today, we're doing a deep dive into this really compelling article from space.com. It's by Robert Leah, just came out July 16th, 2025. And it reveals this potential hidden population of galaxies, like right here on our doorstep.
Exactly. And our mission today really is to unpack this, to explore how this potential discovery, these orphan galaxies, how it could profoundly reshape our understanding of the universe's structure. And critically, how it might just give a significant boost to the leading cosmological model we use to describe, well, everything. It's potentially huge if it holds up.
Okay, let's break this down then. So our current picture, based on, decades of looking, is that the Milky Way has about 60 confirmed satellite galaxies.
Right, 60 confirmed ones. These are the smaller guys orbiting us.
Little companions, yeah.
But what's really exciting here, the core finding from these cosmologists at Durham University, they used a novel technique. And their new research predicts as many as 100 extra satellite dwarf galaxies could be circling our galaxy.
Whoa, hang on. 100 extra?
That's the prediction. These are the so-called missing, or as they put it, orphan galaxies.
So we could be talking about doubling the number of known satellites. That's just incredible. It makes our local patch of space feel much less like a quiet suburb and more like a busy cosmic city we hadn't fully seen.
It absolutely does. And, this immediately brings up a really crucial question. Why is finding these galaxies, these missing ones, such a big deal? Well, if we connect it to the bigger picture, it ties directly into the Lambda Cold Dark Matter model. LCDM, for short.
Ah, the standard model of cosmology.
Precisely. It's our current best explanation, our sort of blueprint, for how the entire cosmos evolved and got its large-scale structure. And just to quickly recap, the LCDM model says about 70% of the universe is dark energy, this stuff driving expansion. Around 25% is dark matter, this invisible stuff that kind of clumps together and provides the gravitational skeleton, if you like. And then there's just 5% that's ordinary matter, atoms, stars, planets, us.
Stuff we actually see.
Right. And the model predicts galaxies formed, where huge clumps of this dark matter gathered first, creating these vast invisible halos around galaxies that stretch way, way beyond the stars we see. And the key prediction is that most galaxies should actually be these little low-mass dwarf galaxies orbiting bigger ones like ours.
Okay, right. And here's where it gets really interesting, isn't it? Because the LCDM model, for all its success, has had this kind of nagging challenge. It always predicted there should be way more satellite galaxies around the Milky Way than we'd actually found, or could even account for in the older simulations. It was a real missing piece.
Exactly. A long-standing puzzle. So the Durham University team, this includes the study leader Isabel Santos and team member Carlos Frank, they decided to tackle this head-on. They combined these really powerful supercomputer simulations with advanced mathematical modeling. And they specifically used something called the Aquarius simulation. Now, this isn't just any simulation. It's apparently the highest resolution simulation ever done of a Milky Way-like dark matter halo. They ran it on their dedicated cosmology machine, COSMA, basically a supercomputer built for exactly this kind of cosmic number crunching. And the key insight, the breakthrough, was realizing that the older simulations, well, they just lacked the necessary precision. They couldn't properly track how these very small dark matter halos, the ones around tiny dwarf galaxies, evolved over billions of years as they orbited something massive like the Milky Way.
Ah, okay, so these orphan galaxies, the idea is they're incredibly faint, right? And they've had their own dark matter halos mostly stripped away by the Milky Way's gravity, which makes them super hard to spot, almost like cosmic ghosts.
That's a good way to put it.
And in those older, less detailed simulations, these faint galaxies just kind of vanished. They got orphaned from the model.
Pretty much, yeah. They fell below the resolution limit or got disrupted in ways the simulation couldn't follow accurately. But in these new high-res simulations, they actually survived. The team could finally trace them.
Okay, wow.
And the specific prediction coming out of this work is somewhere between 80 and 100 of these unseen orphans. And crucially, they didn't just predict the number. They also estimated, where they should be, their distribution, and what properties they might have. It's like giving astronomers a treasure map.
A map to find the missing galaxies.
Exactly. And Isabel Santos, the lead author, she said, and I'm quoting here, "If our predictions are right, it adds more weight to the LCDM theory of the formation and evolution of structure in the universe."
So what does this really mean then, if astronomers do find these fainter satellites maybe using that map?
Well, it would be huge. It provides really strong support, validation even, for the LCDM theory. It helps plug that gap, that missing satellite problem we mentioned. It makes our whole picture of the universe feel, well, more complete.
It strengthens the foundation.
It does. And Carlos Frank, another team member, he put it really well. He talked about the remarkable success of the LCDM theory of galaxy formation and how this work provides, quote, a clear illustration of the power of physics and mathematics. Using fundamental laws and massive computations to predict something real that we can then go out and look for.
It's theory predicting observation.
Precisely. And there's already a little hint, maybe. The team points out there are about 30 recently discovered objects, faint things, that could be satellite galaxies. It's possible these are the first glimpses, maybe a subset, of these very orphans they predict.
Really? So we might already be seeing the tip of the iceberg.
It's possible. Early days, but tantalizing.
And looking ahead, this research could be a vital guide, right, for future telescopes and surveys.
Absolutely. They specifically mentioned the Vera C. Rubin Observatory. That's a major new facility coming online soon. It's designed to survey the sky very deeply and rapidly, and it might just have the power needed to finally spot these incredibly tiny, faint galaxies that have stayed hidden for so long.
So the tools might finally be catching up with the theory.
That's the hope, and you can feel the excitement. Isabel Santos also said, one day soon we may be able to see these missing galaxies, which would be hugely exciting, and could tell us more about how the universe came to be as we see it today.
Yeah. That is exciting. And just for context, these results, they were presented very recently, Friday, July 11th, at the Royal Astronomical Society's big meeting up at Durham University.
Hot off the press, indeed.
So, wrapping this up, the core idea here is our own Milky Way might be home to this bustling, hidden community of dwarf galaxies, lurking just out of sight. And finding them wouldn't just be, adding entries to a catalog. It could actually help confirm our most fundamental theories about the entire cosmos.
It really could. And, it makes you wonder, doesn't it? What other missing pieces of the universe might still be out there, just waiting for the right tools, or maybe a clever new simulation technique, or just a new way of looking at things to finally reveal them. Just imagine how much more we might still have to learn, even about our own galactic backyard.